Hello, welcome to Cracking the Cryptic. This is a very unusual little intro section to the video today because I recorded my solve of this puzzle earlier on this evening, and I wanted to warn you really, this is an extremely hard puzzle. It really is absolutely brutal. It involves some logical techniques we haven't gone through before because they simply don't arise. And I hope for those of you interested in really extremely difficult puzzles, you get something out of the video. It's definitely worth going through if you do like that sort of thing. And I'd really recommend spending 15 to 20 minutes after you see what the puzzle looks like. Just pause the video, try and see how you might make progress. It gives, I think, that'll give you a flavour for just how hard this puzzle is. So without further ado, sorry for the length of the video. That's because my brain couldn't do it any faster. And yeah, I hope you enjoy watching. Hello, and welcome back to Cracking the Cryptic, where we've been asked to take a look at this puzzle from the website www.dailykillersudoku.com. Done one or two of these on the site before, and they're certainly extremely challenging puzzles. I imagine if this has been requested, it's because it's particularly monstrous. So we'll try and solve it logically in a moment. One thing I would say with these puzzles that I've noticed in the few that I've done is that they do tend to have a very linear solution path, which if you don't find it can leave you floundering around for an interminable period of time, wondering how on earth to find the next number. So we're going to have to guard against that. Let's see what we can do now. Okay, well, we can see the 16 cage there. That's got to be a 7 and a 9, and we can write in the value of this cell. Now we have to remember when we solve killer Sudokus that every 3x3 block must add to 45 because it's going to contain the numbers from 1 to 9. If you add the numbers 1 to 9 all up, you get 45. So you can see we've got a 14 cage, an 8 cage and a 12 cage. If we add those numbers up, we get 34. So we know these two cells here must sum to 11 in order to ensure that the whole 3x3 block adds to 45. Well, if these two sum to 11, that has to be a 6. Okay, and looks like we can do something similar with this number. So again, 21 plus 13 plus 10 is 44. So in order to make the block 3x3 block add to 45, we can write a 1 in. Right, now what can we do? Well, one thing I would recommend with these puzzles is to really work hard in the early stages with the numbers that you do manage to solve. So if we look at this 1 here, it might look like we can't do anything with it. We can't do a great deal, but it does have an effect on this block. You can see that obviously a 1 can't go in a 12 cage. It can't go in either of these positions either because we need to make these two add up to 11. So we can't have a 1 in one of these cells. Now, it can't go here or here because of the 1 here. And it also can't go here because if it did, this would be a 7 and that would clash with one of these two 7s. So in fact, I think one of those two positions has got to be a 1. Now, I wonder if we can just... Okay, yeah, now look at the effect the 1 has on this block. Again, we can't have a 1 in one of these two positions because the other number would be a 6 and that would clash here. These ones here eliminate the ones from the top row, so we've got 1s in one of those 3 positions. I'm going to mark that in just because it feels like it might be useful at some point. Now, what next? Okay, well let's have a closer look at this block. See, we have a 20 cage here and a 6 already, so that's 26. So these 3 cells here, in order to add up to our 45 number that we know the 3 by 3 block will add up to in total, if these 6 cells are 26, these 3 have to add to 19. Now, that's interesting because that means this cell cannot take a 1. If this cell takes a 1, these 2 cells have to add to 18, which is too high. The maximum we can make with 2 digits is 17 with a 9 and an 8. So in fact, we also have a 1 in one of those 3 positions, which might be useful in the fullness of time. Well, now let's look at this middle block. You can see we've got a 25 cage here and 2 14 cages, which each have 1 digit sticking out. So if we add 25 to 14 and 14, we get 53. So now again, we know this 3 by 3 block will add up to 45 altogether. So these 2 cells here, this cell and this cell, must sum to 8 in order to reduce that 53 total back down to 45. Now, if these 2 sum to 8, this cell all of a sudden starts to be a little bit more restricted than one might first think. Oh yes, look, because it can't take a 1 because of the work we just did. It can't take a 2. If it takes a 2, because these 2 numbers have to add to 8, this would be a 6. That's not possible. So, let me delete it. Oh, I have to put in the number again to delete it. So this cannot be a 2. Can it be a 3? Can't see why it can't be a 3. Can't see. So 3, 4 would make, so that's 5 and 4 here. Can't see a restriction on this cell yet. Oh, don't forget as well, we've got to use the fact that these 3 add up to 19. So this is going to be very helpful, I think. So 4. Yeah, I can't see why 4 isn't possible. Let's just do the math. So 3 here would mean this would have to be 7 and 9. 4 here combining with means this has to add up to 15. So that's going to be, oh, it can't be a 6 now. That's going to have to be an 8. 5. Well, 5 is an interesting number, isn't it? Because look what happens if this is a 5. If this is a 5, we end up with a repeated digit, because if this is a 7, 5 plus 7 is 12, we know we have to make 19, so this would be another 7, and that fails. If, on the other hand, this is a 9 and this is a 5, that adds up to 14, and this would be a 5. So either way around, we get a repeated digit, so 5 is not possible. 6 isn't possible, we already have a 6. 7, that's probably possible. Okay, 7 is possible. This is 7, this would be 9, this would be 3. Now, oh, and 8 is impossible, because if this is 8, this has to be a 0, because we know this and this have to add to 8 altogether. So that can be not 2, that can be a 1. So this is a 3, 4, or a 7. Okay, now I wonder if that's going to help us to make more progress. We should probably look at this 7 cage. Yes, because, right, this 6 means this cannot be a 1-6 combination. Now, if this is a 3-4 combination, which is one of the other alternatives, you can see immediately this would be a 7. So we'd have 3, 4, and 7 in row 3. How do we fill this? We can't. It can't be 3, 9, because there's already a 3. It can't be 4, 8, because there's already a 4. And it can't be 5, 7, because that's forced to be a 7. So this cannot be 3, 4. This can only be 2, 5. Let's write that in. Now, is that going to help solve anything? See, everything's getting quite restricted over here now. Let's just have a think about this for a moment and see if we can spot anything further. I'm wondering whether we can use the 5s here to make more progress. You can see, if we look at this block, where can a 5 go? Well, the interesting thing is, not only can it not go here because of this 5 here, it can't go here either, because if this is a 5, this is a 6, and this would have to also be a 6. So there's no 5 in these two cells, there's no 5 in these two cells, so either the 5 is part of the 8, or the 5 is part of the 14, in which case this would have to be 1, 5 and 8. Right. Whoa. Okay, well this is... Right, we're now venturing off into the realms of extremely advanced killer Sudoku, but because we have this strange equal sign here, we can use parity, I think, to make more progress. So we've established that if the 5 is in this 14 block here, then this 14 block would have to contain an 8 as well, because we know it contained a 1, so it's going to be 1, 5, 8. Yeah? And look at the effect that has on this cell. This cell cannot then contain an 8, so it's going to contain a 3, 7 and 9. Now what happens is this 19 sum here can only be made, because this 8 disappears. Let's just show you that. This 8 disappears. Therefore this 4 also disappears, because the only way of making 19 now with the numbers 3, 7 and 9 in these two cells would be with a 3 or a 7 down here. So we know we're going to have 3, 7 and 9 in these three cells. Now we've worked out where a 1 goes. Okay. Now that's 4 of the odd numbers already used. Now we know this row in total is going to add to 45. Okay, now we know this is an even number. We know that these two, this and this, they'll either be, because they're equal, they're either going to be 2 even numbers or 2 odd numbers. That's just a statement of fact. Yeah. Now, if you add up 2 odd numbers, what do you get? You get an even number. And if you add up 2 even numbers, what do you get? You get an even number. So, we know that the total of this and these 4 numbers is an even number. So we know that when we add the 7 cells, these 3 and these 4, we will get an even number. Now what does that tell us about these two cells? What must they add up to, given that the whole row adds to 45? They must add to an odd number, i.e. they must contain an odd number. Well, that is now impossible, because look, we already have 3, 7 and 9 being used down here. We have 1 being used here. So the only odd number left to be included here in these two cells is a 5. And we can't have a 5 because we already have a 5 in the row. So that is a convoluted way. Sorry if that's a bit involved, but I thought it was worth going through of showing that actually, I want those to be small, the only place that we can put the 5 now is in this 8 cage. So let's put it in there. That means that we've got a 3, 5 pair now, which is great because that fixes the 12. That's now got to be 4 and 8. These two cells sum to 11. That's only possible now if we have the numbers 2 and 9. Everything else is ruled out by this combination. We have a 9 here already, so in fact we get to write another number in. That's a 9 and that's a 2. And this must be 6 and 7 in there now, which means we can eliminate this 7 here. And that means, again, we can eliminate... Oh, I think we did have an 8 in there before, didn't we? Which we need to leave in there now. That's still possible, I think. 2, 2, 5, 2. Oh, that's interesting, isn't it? So if you look here, we have 2, 5. And if you look here, we have a 5 here and a 2 here. So I need to put a 2 and a 5 in these 3 cells. Well, from the work we did earlier, there's no 5 or a 2 here. So in fact, these 2 cells must be 2 and 5. Okay. Now, what numbers are we left with for this top line? We're left with 3, 4, 8, and 9, and we know that they must add up to the same number. But we can eliminate the 4 from here because we've used a 4 and an 8 here. So I can eliminate that 4, which means this can no longer be an 8. Because we know these 3, again, just to go back to it, these 3 are adding to 19. So if this is 3, 9 now, and we know this total and this total are the same using the numbers 3, 4, and 8, this must be 3, 9 as well. This must be 4, 8, 4, 8. Okay, so we're making a little bit of progress now. 8, 4, 8. Okay, I need to put the numbers 4 and 8 in the middle cells here. So in fact, that forces the one. One's going to have to go there, and this is going to have to be a 4, 8 pair. Let's pop that in, and what are we left with? 1 and 6 into these 2 positions, and this is a 3 or a 6. Can't be a 1 anymore. This is a 3 or a 7, like that. Okay, wow. These puzzles are extremely difficult. What can we do now? Well, this 3, 7, we know that this and this add up to 8, so I can remove the 4 now. This is a 1 or a 5, but I don't think I can tell which yet. Well, now if we look at this arrangement of 9s now, you can see that we've got this funny arrangement of 9s in these 4 cells. So if this is a 9, this will be a 9. If this is a 9, this will be a 9. Either way, there are no 9s at all down here. There can't be, because otherwise we're going to break this, this sort of box of 9s that we have here. So if there are no 9s in any of these positions, what does that tell us? Well, there's obviously, if we look at this 3 by 3 block, this can't take a 9. So the 9 is either here or it's in here. But in fact, this cell is quite restricted, because if we look at this 3 by 3 block now, you can see that, well, this number and this number have to be the same because of this equal sign. So this cell is actually already quite restricted. In fact, let's think about what the options are here. If this has to be a number bigger than a 3. If this is a 3, this would be plus 8 is 11. These 2 would have to, well, so we're halving 34. So this would have to add to 17. These would have to add to 17. But now these can't add to 17, because if they do add to 17, they must contain a 9, and we know there are no more 9s down here. So this is not 3. We know it can't be 4, because then 4 plus 8 obviously is 12. Deduct that from 45, 33. You can't halve 33 and get an integer. So we're looking at odd numbers in these positions, that's for certain. So 5 and 8 is 13. That's going to give us 32, which gives us 16. Again, 16 is not possible, because then these 2 would have to be 7 and 9, and we'd have 3 cells containing exactly 2 numbers in the column, so that breaks. That's not possible. And this is not 5. So this is 7 or 9 now. Okay, well, if it's 7, these have to add to 15, not using a 7, so it'd have to be 6 and 9 again. Well, that's impossible because we've shown that there's no 9s anywhere down here. Good Lord. So this is not a 7, this is a 9. Let's remove the 6 and the 9 here. Now if this is a 9, 9 plus 8 is 17. This is adding to 14, not using a 9, so this is 6 and 8. Okay, now that might be useful, maybe. Let's try and work out how. 6 and 8. Wow. Well, okay, let's do Sudoku rules now on this block. Trying to see whether we can use this in these 9s that we've got in this position and this position. You can see there can't be any 9s here, can't be any 9s here, and there can't be a 9 here. If this is a 9, this would be a 1, which will clash with this one. So the 9s in this block are limited to those two positions. Now, yes, lovely. Okay, so now we have a 9 here and 2 9s here. So again, simple Sudoku rules. We need to place a 9 along one of those 3 positions. But we know this can't be a 9 because we did all that work earlier that showed there are no 9s left in column 6s and 7s. So there is a 9 in one of these 2 positions. And now this can't be a 5. If this is a 5, we need the other cell to be a 0, which is impossible. So this is a 5. This must be a 7 now, which means this is a 3. And that, wow, that's going to really help. 3, that's 9, 7. Okay, the other number here must be a 4. Perhaps worth noting we've now got 2 4s here and 2 4s here, so we know that the 4s in this block are going to be down this side of the grid, in case that's helpful later. 1, 1. Ooh, can we do anything with the 1s now as well? We've got, oh, this has to be a 1 by simple Sudoku rules. Let's put that in. Oh no, that's not right. I was misreading this one and thinking it was here. 1, 1. This can't be a 1 because of this 13. Obviously, if this was a 1, this would be a 12. So there's no 1 here. This can't be a 1 either because it's a 14. So there's a 1. Ah, yeah, and there's a 1 in one of these 2 positions. But obviously you can't have a 1 here because then this 1 would be repeated. So this is a 1. Which means that was right in the end, but actually we've proved it now, so that's good. 1, 1, 1, 1, 1, 1. So 1 in one of these 2 positions. 9, 9, 4. Quite see how to make that work. Another tip. Another tip I've noticed when I've solved these puzzles on this website before is that there is quite a lot of use made of the logic that says where can a number go in a 3x3 block. And what I've often seen is that where you have an even numbered cell like this, you can see that we can't have a 4 obviously in either of these 2 positions. And that logic, I mean, it's quite unusual, but it's very powerful here actually, because look, we have a 4, 9 we've managed to isolate down there. So the fact there's no 4 in either of these 2 positions locks a 4 into one of those 2 positions. And maybe we can, yes, and look, now this cannot be a 4 here, because if it is, this would be a 9. It's 13kh. So the 4 over here is locked into one of those 2 positions. And now you can see we have the same arrangement of 4s here that we had with 9s up here. So we now know there are no more 4s anywhere there in columns 1 and 2. So there is a 4 here or a 4 here. Oh, that's close to being useful, isn't it? This cell is quite restricted actually. you can see that this 1 here means these 3 cells add to 18. Plus 14 is 32. So these four cells here sum to 13. Now, obviously, if this is a 9, for example, which is possible on the face of it with a 13 cage, that's not possible in this instance, because these 3 numbers would then have to add up to 4. The minimum that 3 numbers can be is 6 if they're 1, 2, and 3. So this can't be a 9, it can't be an 8. It can't be a 7 either, because if it's a 7, this would be a 6, and that gives us a problem with that 6. So actually, oops, this is a 4, 5, or 6. So that's a 7, 8, or 9. And that might be even more restrictive. We just proved the 4 was in one of these 2 positions. 13. So now, where, again, actually this is a good point. Where can we now place a 7 in this block? By the same logic we've just used with this 8 cage over here, where we said there can't be a 4 in either of these 2 positions, there cannot be a 7 in either of these 2 positions. There's no 7 here. There can't be a 7 in either of these 2 positions, because if there is, we know these 4 numbers are adding up to 13. So the other 3 numbers would have to be 1, 2, and 3 in some order, and we know this cell cannot contain one of those options. So the 7 is in one of these 3 positions. Might not be useful, but might be. So we've got 8, so we know that we have to make 11 from the other 2 digits in this cell. Oh look, we can do some work on this 13 cage now. 4, 9 is impossible because of the 9 here, and 6, 7 is impossible because that's now limited to a 6, 7. So in fact this is 5 and 8. And that must be helpful. Let's think about this now. We've got 13 in this cage altogether at the moment, so we need the other 2 numbers to add up to 8. Without using 1, 7, without using 3, 5. So the other 2 numbers here have got to be 2 and 6. Let's put that in. Which means these 2 numbers here are 3 and 7. Okay. Just wondering about the options here. We know these 2 cells have to add to 7 without... Is there any restriction we've got on that at the moment? 6, 2, 5, 3, 4. 3, 4 would have to be that way. I can't have... Sorry, what am I talking about? 3, 4 is impossible. So this is either 2, 5 or it's 1, 6. It's 1, 6. It has to be this way round. Or it's 2, 5. So what do we need to put into 2, 5, 6, 8 into row 6? It's not restricted there. That is restricted because we have a 6, 8 pair here. So these 2 cells have to be 2 and 5. And this has to be a 6 or an 8. 2 and 5 here, that must help, surely. 2 and 5, 2 and 5 pair up here. This 8 cage now, it can't contain a 2, 6, can't contain a 3, 5, must contain a 1, 7, which must be that way round. 7, 7, 1. So this can't contain a 1, and that can't be a 6, so that's got to be a 2, 5 pair, so that's not a 5. Resolves that conundrum there. This doesn't contain a 2. Well, this doesn't contain a 6. Okay, so this number must be a 3. I think that's the only option left for that number in the row. 3, 3. We've got to put a 3 into one of these cells, so it's got to be there actually. That's going to be 4, which means we can write 4 in there. That's going to be an 8. 4, 2, 5, 8, 8. I think we're nearly there now, but given how hard this puzzle is, I think it's probably beholden on us to actually take the trouble to finish it off. This 5 here means we can eliminate that 5 there, which means we can eliminate that 8 there. 4, 6. Need to place a 1 in the middle box somewhere. It can only go here now, I think. What numbers are we missing? This has got to be a 7 or an 8. So we've got 6, 7, 8 to place, and that can be a 6, 7 or an 8, I think. So 6, 7 and 8, that adds up to 21, plus 1 is 22, plus 3 is 25. So it does look like it's we're on the right lines here, I think. Is that a 4, 7, 8, 9 quadruple down this column? 4, 9, 7, 9, 7, 8, and 4, 8, I think it is. So this must be a 2 or a 5, I think we can prove from that. Okay, let's just check whether there's anything more we can do with these. We know these add to 13, so this is a 6 and a 1. These would have to be a 2 and a 4, and that would only be possible in that way round. This is instead of 4 and a 1, we need these two cells to add to 8, which means that they've got to be, you can't use a 1 and a 7, so it's got to be 3 and 5, which would have to be that way round. Or 2 and 6, which, oops, I need to do that. 2 and 6, which would have to be that way round. So again, this square here is very restricted, but not quite in a way we can use. Let's just check this box now. So you can see we already have a 1 here, and we have 24 in this cage. So we know 1 plus 24 is 25. These 3 cells must add up to 20. Well, that's not possible. This can't be a 2 anymore, can it? Let's just check that. Yeah, this has got to be a 5. These 2 cells now must add up to 15. So that means we've got a 6 or an 8 into that position. That's nice. That gives us a 6, 8 double there. This 5 we can use up here, look, and resolve that. Oh, that is nice. That gives us this and this also. 2, 2, 2 in one of those 2 positions now. And the other number will have to be a 4. Okay. Okay, so what now? Well, we can see one of those numbers has to be a 1. That might help us. It's 14 box. It's got to be either 6, 8 or 5, 9. Obviously, I've sort of held off looking at it because, oh, that's ridiculous. Okay, well, let's look at this. Mark did a video a few days ago of talking about uniqueness in columns. Now look at this, what we've got here. If this is a 6 and 8, there is no way of resolving which way round it goes. Because, let me show you what I mean by that. Let's start off with a variation where this is a 6, okay? So that if this is a 6, this will be an 8. You can see this will be an 8 now, and this will be a 4, and this will be a 4, and this will be a 6. Let's just do it for good order. So that's going to have to be 4, and that's going to be a 6. So this would be one solution. But hopefully it's clear to everybody that if I simply reverse the order of this, put the 8 here instead, then I will just switch around this number, and I'll have another solution. So if I looked at the finished solution, I would be able to transpose these numbers and come up with a second solution. There is no way of resolving which version is intended to be correct. And we know that good puzzles have one solution. So that being the case, this extraordinary puzzle, we can eliminate the 8 and the 6 here and know that we're looking at a 5 and a 9. Now that must finish it surely. So this is now a 7. This is a 6. Now as this is a 6, we know these add to 13, so we now know that we must be looking at a 4 and a 2 here, so we can resolve that little dilemma. This can't be a 6 anymore. That's now got to be a 6 here. 4, 6 like that. Don't want to make a mistake. That would be very irritating at this point. This can't be a 7. That's got to be the 7. Lose that from being a 7 there. 9, 9. Go any further than that? Probably can, but I'm not immediately seeing it. That's one of the problems with live solving, is sometimes it can be, oh, we can fill in this now. We know this has to add to 15, so that's an 8, which resolves this. Can't be an 8 now. That's got to be a 6, obviously. That means this isn't a 6. 2, 5. Let's look at these options here. So you can see that this is now 3, 6 and 9. So that means this can't be a 9. That's got to be a 9 like that. That can't be. That's got to be the 8, I think. Which means that this is a 7 and this is the 8. Ah, the 2, 9 was resolvable. I just wasn't seeing it when it was staring me in the face. So that resolves this way round. That's got to be the 9. That's got to be a 5. 3, 5 that way round here. I will say I think this puzzle is, well, it's two things. It's exceptionally difficult and exceptionally interesting. I mean, probably in this one video, which is going to be extraordinarily long, we have covered every single complicated technique you'll ever find in a difficult puzzle. You can see simple Sudoku rules now give us an 8 here, which resolves the position of the 1. So this now has to be a 1. This can't be, this has to be a 3 in fact. Eliminate the 3 from those two positions. 7, 3, 7. 2 or a 4. We know this box obviously equals this box, so we're now really running into quite a lot of restrictions in terms of what this can all be. Simple Sudoku rules. This has got to be the 1 in column 8. So there's a 6 here. We need a 6 in one of those two positions. Put a 3 in one of these two positions. 8, 9, 9 in one of those two positions. So it's a 6, 9 pair there. And you can see, if you're worried about uniqueness, because we have this 6, 9 arrangement here, this is going to be fixed by this equal sign. And that's, I suspect, why that equal sign is going to have proved necessary, is that they needed to ensure that there was a unique solution to the puzzle. So interesting point there. If this equal sign wasn't here, then we may well run into a uniqueness problem. So let's just test this. If this is a 2, so that's going to be 11. This would have to be a 6 and a 5. Can't be a 5 because there's a 4 or a 9 and a 2. Can't be that because we've already just used the 2 when we made that. So this in fact is going to be a 4, which means this is a 4, this is the 2. So now we know these have to add to 13. We can't use 9 and 4 now because it's totally broken, so I'm hoping this can still be a 7, and it can. And that is our final step, I think, in terms of finding the solution. What an excellent puzzle. So now we can eliminate that. This has to be the 9. This has to be the 7. This has to be the 3. Eliminate that 3 there. That must be a 2, I think. That's going to resolve this stuff up here. And we're left with this cell, which I think, if we look at it, that's going to be a 5, and that looks like it's all working. So I hope this has been educational. I don't think we'll ever cover a killer Sudoku with so many different techniques and advanced techniques. Fantastic, thanks for the recommendation. And if you do enjoy the channel and these extremely hard puzzles on occasion, please do subscribe. We really appreciate it. Thanks for watching.